Hello everyone. So today we are going to start normal distribution. Earlier you have some idea about binomial distribution or Poisson distribution as well. This time we are going to start with the normal distribution which comes under continuous probability distribution. See, I have taken here one question. The length of bolts produced by a machine is normally distributed with mean 4 and standard deviation 0.5. A bolt is defective if its length does not lie in the interval. This is an open interval which is 3.8 and 4.3. An open interval has been given here. Find the percentage of defective bolts produced by the machine. So here we are going to use the concept of normal distribution. You need to remember two things before using the normal distribution. That you are not supposed to work with this 3.8 and 4.3, these two values. You need to change it to its equivalent standardized value. So first our objective is to change this interval to its equivalent standardized value. So let's start. See, what are we supposed to find here? Find the percentage of defective bolts produced by the machine. So defective if it does not lie within this specific range. That means if it crosses this specific range which is 3.8 and 4.3, then we are supposed to consider that as defective. So now probability that C less than X less than D. Suppose here I am taking two different values which are C and D. So we need to change this C to its equivalent standardized value and D also to its again standardized value. So how do we change it? You need to remember a formula here. It is C minus mu by sigma, and here as well it is Z and D minus mu by sigma. You have to remember one thing. Whenever you are using C minus mu by sigma for this equivalent standardized value, at the same time you are performing the same thing with this X, which is X minus mu by sigma. X minus mu by sigma is basically the value Z, and D again to its standardized value D minus mu by sigma. Now look at the question. It is mentioned in the question that the mean is 4 and the standard deviation is 0.5. That means here you are supposed to consider the value of mu as 4 and the value of sigma as 0.5. So let's just substitute. So probability, the range has been given to us as 3.8 to 4.3. That's what we are substituting now. Now look at this. C I have taken as 3.8. The mean has been given in the question, that is 4. So I will substitute the same, and sigma is 0.5 less than Z less than, again 4.3 is the value of D, so I will write it here 4.3 minus 4 by 0.5, it is 0.5. So what answer are you getting? You see, probability minus 0.2 divided by 0.5 less than Z less than 0.3 by 0.5. So what are you getting in the next step? Probability of minus 0.4 less than Z less than 0.6. Next we need to remember one thing, that whenever you are changing one specific value to its equivalent standardized value, either you have to follow the standard normal table, that means the table which is available, you see in the appendix of your book, it is given, else the values shall be given in the question itself. In this particular question, as you can see, the values are given. So we are going to use it, but you need to understand how does it work. So let's draw a standard normal curve and let's just identify the area. See, the value which we are going to consider here, it is in between minus 0.4 and 0.6. So of course minus 0.4, I will consider the ordinate on the left side of 0, which is minus 0.4, and here it is 0.6 suppose. 0.6. So basically we are supposed to find out this area. Look at this. This area we are supposed to find out. Now the question, read the question. Here this is the distribution. That's a normal distribution. The range has been given as minus infinity to 0.6 and this area is given as 0.7257. Again this is the normal distribution. It is given minus infinity to 0.4. The value is given as 0.6554. So first what we are going to do is we are just trying to identify these two regions using a standard normal diagram. So minus infinity, so look at this, it would be easier for you to identify. Here it is minus infinity till 0.6, the value has been given. This entire value is given as, see the value, it is given as 0.7257. This entire area is 0.7257. Now you all have some idea about the standard normal curve. You see on the left side of 0, we are going to consider the area as 0.5. On the right side of 0, we are going to consider the area as 0.5. That means if I ask you to find out the area between 0 and 0.6, this is going to be, that means this area is going to be 0.7257. That means the total area minus 0.5. So what are you getting? It is 0.2257. So see, from the diagram this area we are supposed to find. On the right side of 0, we are getting this area as 0.2257. Similarly, the next diagram, again we are going to draw it. It is also given as 0 to 0.4. This time it is minus infinity to 0.4. The total area is given as, see, 0.6554. So this entire area is 0.6554. As I already have told you, on the left side of 0, the total area is 0.5. So on the right side of 0 this time, this area, in between 0 and 0.4, it is 0.6554 minus 0.5, which is 0.1554. So now I can substitute this value here. Why? Because here it is indicating in the area in between minus 0.4 and 0. You need to remember the standard normal curve, it is a symmetrical curve. That's why the area on the left side of 0 is equal to the area on the right side of 0. So I can consider this value as 0.1554. So finally the total area is, which we are going to find out here, it is 0.1554 plus 0.2257. So the sum is 0.3811. 0.3811. That's the area which we are getting as per the question. Now let's see the question once again. It will be easier for you to understand now. See, a bolt is defective if its length does not lie in the interval. So this region we already got here. The probability is As per the question, it is showing the probability as 0.3881. So if it fails to lie within the specific region, the area will be 1 minus 0.3811, which is equals to 0.6189. So I can conclude it in this way: the area or the probability that a bolt does not lie within the specific range is 0.6189. 0.6189. That means 61.89% of the bolts are not within this specific range. Now you see the question once again: how many bolts have you taken here? See, as per the question, here the length of the bolts produced by a machine is normally distributed with mean 4 and SD 0.5, and you are supposed to find out the percentage of defective bolts produced by the machine. So the answer would be 61.89% of the bolts are not within this specific range. Thank you.